Okay, so let's solve today's LeetCode problem, daily problem. So, if you solved yesterday's problem, both are similar, but this is a hard problem. Yesterday is medium, and let's understand the problem. So, we have an array, and uh, we are initially at index 0, and uh, we can do three operations: I plus 1, I minus 1, j. We do three jumps. It means either we go one index forward, one index backward, or index j, where arr of I equal to array of j and I doesn't equal to j. Means we go some other element whose value is same at our current index value. So these three kind of operation we can do, and our goal is to return the minimum number of operations to reach at last index n minus one in this case. Okay, so yeah, for this answer is three. How it is three? Uh, the first operation it do is from this 100 to here, this 100. This is one operation. Okay, then second operation, why this we can jump to this and because both have same value. Then we can go plus one minus one also. So then the best operation, best jump is to go from 100 to one less index 404, and from here we can jump same value index, which is last index. So this way, there are three operations: 100 to 100, 100 to 104, 104 to 104. Okay, 404 to 404. Yeah, sorry. For some special cases when array value is uh, length is 1, then we have to return 0 because this is the first and last both. Uh, this is something that first and last index have same value, so it simply return 1. Okay, so by looking at the question, uh, it already have we have some edges or relations between paths between nodes, and we are returning. We have to return minimum path to reach minimum this last index. So whenever these kind of question came, graph is the one from which we have to think these questions and try to solve using graph. And in the graph also, by looking at this question, if you solved some questions in graph, then it is more like of BFS question whose where like we have to find minimum paths using traversal. So that first search is one of the solution. Yeah, so let's think about it. We start traversing from here, and then we insert all the edges in the, like we traverse process this and insert all the its adjacent values nodes, and then process those values. So we can solve this by graph. Yeah, so for this, the first thing, it is a simple uh, BFS question. Let's try to solve all and see how many test cases we have covered or we passed. Okay, so first we need this array size, then we also need a visited array. whenever we traverse an element, we have to mark this element as visited. Okay. Okay. So because we have to find minimum path, are we have to traverse level by level. We can say here I can use I. Okay. This is one level. When you process this level, I have to increase I plus plus. Okay. Mm, Also, we have three operations to perform. One plus one minus one. To perform third operation, I think we should require a map where we can store uh, all the indexes with same value. Traversing in this array, and on every value, I'm just storing its index. So when we encounter same value, then the array size we push into the same array because key is the value. Uh, okay, one more thing. Q dot push. Initially, I am at index 0. I have to push 0 because, and also I'm marking this as a visited. Yeah. So here we have to process the first node, Q dot to front. We can say v1 equal to u minus 1, v2 equal to u plus 1, and if a1 greater than equal to 0, because we are decreasing the value, we just have to check one uh, case. Also, if it is still not visited, this is also uh, required. If this is still not visited, then what I can do? I can simply push this value into our queue. Also true. The other case, the second node v2, we just have to check it's less than here. It is less than n, and it is still not visited. Then I have to push it and also mark it visited because we have to avoid push any value twice in the queue. Okay. Then third case for which we made this map, the same value case. Or to I can say V. These are edges. These are direct edges. These are the nodes where we can traverse, we can jump directly because they have same value. Okay, map ARR. No, here is due. if v doesn't equal to u, because we have to avoid same index, and this of v equal to false, then only we have to push this. Mm, okay, now we have this. Can I simply return here this text? Oh, the first case, after processing this step is a 1. After processing 1 and 2, step is 2. After processing this, we have these 3. In the queue, we have 1, 2, and 3. Step is still 2. When we are start processing these elements, then at the end step is 3. Okay. Here I can write if u equal to n minus 1, which is our best guess or answer. I have to return a step, because when I am processing these elements, these two are inserted and this is also inserted. I got 3 and no, here the first level is 0. When I am processing, step is 0. When I am processing these two, it is second level. Step is 1. When I am processing these, step is 3. When I am processing this, because from here we can jump to here. Answer is 3. Yeah, it will work. Okay. Okay, we are storing value as u. The key is array of u, not u. Then we are getting indexes here. Q dot pop. But okay, that's why we are getting a Stack Overflow, I think. Okay. Here I had to do this. Now it's returning true. Okay, let's submit this question. Okay, now we are getting this error. It is true because it means every node have edge with every other node. So every time we are traversing this for each node, we are something like doing n square operations. So, and there's so here, based on these constraints, n square solution will not work. Okay, we have to do something smart or something. I am already marking it visited equal to, but the first time only we goes into this condition. After that, we don't have to come into this condition, but it is looping this again and again, because it's find a map. Oh, okay. Okay, one thing. Let's take this example. I think I have a solution here. Hmm, because this is 7 and we are uh, reaching to each 7 from here. And once we reach from this first value to every other value, does it make sense to reach this 7 to this 7? Not, because the minimum path is from first 7 to suppose this 7. So again we are pushing this because this is a second level. Second level have these all the indexes. Although we have our answer in the queue, but first we have to process all these elements also. And because we already got our minimum path, if it doesn't require these 7 to again goes to these other nodes, because then the length is 2. If suppose I'm taking this example from here to, if I go to any other node, then length is 2, although I already reached from here, which is length 1. So again we don't have to do any operations. So I think here, yeah, what I can do, I can delete these the key, because I already did with minimum path, and I, from here I don't require any other thing. I think this will improve our time complexity, because I am traversing only once. Okay, let's submit it. Okay, so it's successfully submitted. Although our solution is not the best one, but we are able to solve this question. Okay. So this is today's LeetCode daily question, and it is a graph question. Yesterday is also similar question. You can do that also. And in morning also I tried to solve this question, but I stuck here only.